All right, Math, hey, we got a new unit. So here we go. Lesson 2-1, Graphing Linear Equations Vocabulary. So let's go ahead and start on this other page first. So we've got here a whole bunch of vocabulary words over there. Kind of hard to see it from where you're sitting, I think. But anyways, here we go. So the coordinate plane. This whole thing is called a coordinate plane. So that's the name of this whole thing that we're going to be graphing on. A lot of you just call it a graph, but it has a cool name. It's called the coordinate plane. Plane just means something like flat, so two-dimensional, so that's why this is a plane. And then it has a bunch of coordinates on it, so it's called a coordinate plane. There we go. Next one are coordinates. So coordinates are like this, 3 and -7. That is a coordinate, which goes on the coordinate plane. These have another name to them. They're also called down here ordered pairs. And they're called ordered pairs because they're pairs too, and ordered because they're in a certain order. The first number is the x-coordinate. There's not a lot of room on these. So that's the x-coordinate, the first number. The second number would be the y-coordinate. And in case you find it hard to remember, the x's go left to right. And then the y-coordinates go down to up. All right, what else do we got here? A diagonal line. So this right here is a diagonal line versus a vertical line or a horizontal line. So that is a diagonal line. A horizontal line, like the horizon, a horizontal line would go side to side. So this is a horizontal line. And then a vertical line. Oh, where's vertical line? Oh, vertical line's way down there. Let's just do vertical line. It's this one over here. Oh, let me move so I can actually write there. Okay, so that's going to be a vertical line. Okay, what else do we got? Ordered pair, so that was 3, 7. The origin. The origin is the point 0, 0. This is the origin right here. It has an x-coordinate of 0 and a y-coordinate of 0. Right there is your origin. What else we got? A point. So this over here, the origin is technically a point right there, but this over here is a point that they've got going. So we would call that a point on the graph. We could also say that this 3, -7, the ordered pair, that represents a point on the graph. A quadrant. We actually have 4 quadrants of the graph. So here we've got our 2 axes, and it splits it up into 4 separate quadrants. So our first quadrant is over here. So this is called the first quadrant. And they use Roman numerals for quadrants. I don't know why, they just do. But in the first quadrant, the x is positive and the y is also positive. So all ordered pairs in this quadrant will have a positive x and a positive y. And then for some reason, the quadrants go backwards. So instead of going clockwise, the quadrants go counterclockwise. This would be quadrant 2. In quadrant 2, we're going backwards over here, so we're going to have negative x's and positive y's. And then going in our weird direction, we're going to go down to here. This over here is our third quadrant. But of course, instead of using just the word third, we use Roman numerals. Don't know why. In the third quadrant, the x's and the y's are both negative. And then over here, this is our fourth quadrant. So over here, our x's are positive, but our y's are negative. And IV is the symbol for 4 in Roman numerals, because they liked it that way. All right, so there we've got our quadrants. We've got our vertical line. We've done that one. The x-axis. The x-axis is this line right here. So this is our x-axis. So the x-axis goes all the way across. This is the positive side of the x-axis. And over here, after the origin over here, this is the negative side of our x-axis. Y-axis goes right here through the origin. We've got a positive side of the y-axis up here. And then down here, after the origin down here, we've got our y-axis that's negative. An x-coordinate and a y-coordinate, we did those ones. This is the x-coordinate, this is the y-coordinate. An x-intercept. Okay, anytime your line crosses the x-axis, so this is our x-axis, we would call that an intercept. So I can see that this diagonal line is going down, 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 and right here, boom. That line crosses the x-axis, and we would call that the x-intercept. Over here, this vertical line also has an x-axis right here, or x-axis, x-intercept. Because it crosses right here at this point. So anytime any lines cross our x-axis, we call that an x-intercept. Now, y-intercepts, we've got this diagonal line. You'll notice that this line, when it's diagonal, has both an x-intercept and a y-intercept. So that would be its y-intercept over here, because that's where it's crossing the y-axis. And then over here, a horizontal line. This horizontal line down here crosses the y-axis right here, so we would call that a y-intercept. Notice that it's only the diagonal lines that have both an x and a y-intercept. This horizontal line has a y-intercept, but no x-intercept, whereas the vertical line has an x-intercept, but no y-intercept. So if you've got vertical or horizontal lines, they're only going to have one intercept, but if you have a diagonal line, it will have two intercepts, both an x-intercept and a y-intercept. All right, I think we covered everything. Okay, so the coordinate plane is formed by a horizontal line right here, which is called the x-axis. A lot of room to write here, x-axis. And a vertical line, a vertical number line, the y-axis. Each blank point on the coordinate plane has an address called the ordered pair. Which has an x and then a y. So here we've got this point back here. This point has an address. We would always state the x first, and you can just count 1, 2, 3, 4, 5, 6, 7. So we went 7 to the right, and then up 1, 2, 3, 4, 5, 6. So this point has an address. It is called the ordered pairs. and this is 7, 6 would be that point right there. The point where the axes cross, that's this point here, is called the origin. Ooh, I got mail. And then its coordinates are 0, 0. The blank equation with two variables has a blank number of solutions. So it is a, wait, did I skip one? I skipped one. I did. The blank gives the location on the x-axis, that's the x-coordinate. And the blank gives the location on the y-axis, the y-coordinate. Now this one. A linear equation. First part of linear is the word, ooh, you can't see anything I'm writing. I wasn't paying attention. I apologize. I'm not going to redo that. You'll just have to catch up. So we've got x-axis, y-axis, point, ordered pair, origin, x-coordinate, y-coordinate. Oh, that was 0, 0. Okay, anyways, a linear equation has two variables in it and has a blank number of blank. And these words are infinite number of solutions. Okay, so let's take this diagonal line here. This diagonal line has an equation that represents that line. We're not going to get into it right now what that equation is, but each point on that line is a solution to the equation. The equation has an x in it and it has a y in it, and we can come up with an infinite number of points. See these arrows here? This arrow means that it goes forever. So we're going to have an infinite number of solutions. That x-intercept has an ordered pair. It has an x and a y. This number here has an ordered pair. It has an x and a y. We've got some more points all over the place. So all of these points on this line have their own x and y, and all of them are solutions to the equation. We can plug numbers into the equation or find points on the line all day long. There's an infinite number of points on each line. Each solution can be represented by a blank, by a point on the coordinate plane. So each point on the line is a solution to the equation. These points form a line called the graph of the equation. And we'll get a little bit more into that in some other lessons. All right, so every point on the line is an equation, is the solution to an equation. And when we plot the points of an equation, that's called the graph of the equation. All right, a little bit of practice here. Circle the ordered pairs that are solutions to the equation 2x plus y equals 0. So we want the equations that will make this work. So let's just plug it in. 2 times 8 is 16, and then plus 2. 16 plus 2, that's 18. That does not work in that equation. So this line would not go through this point. 4, 2. 2 times 4 is 8, plus 2 is 10. That one does work. 8. 2 times 8 is 16. 16 minus 6 is 10. So that works. So this line would go through that point. -2. So if I plug in -2 here, I get -4. -4 plus 6 is not 10. So that one doesn't work. 5. I get 10 plus 5, 15. That doesn't work. It has to equal 10. If I plug in 0, 0 plus 10, that does equal 10. So that is a solution to the equation. If I plug in 5, 2 times 5 is 10, plus 0. Yes, that's equal to 10. So that's a solution. 3.5 plus 3, oh goodness. 2 times 3.5 is 7. 7 plus 3 is 10. That is a solution. So you can have decimals also with your points, your ordered pairs. They don't always have to be integer values. Last one, if I plug in 1 and 2 here, I get 2 plus 2, which is 4. That is not a solution. So you can see here, just with this one equation here, 2x plus y equals 10, I've found 5 different solutions. Remember, there's an infinite number of solutions. If I plotted all these points, the line would go right over all these points. All right, plot the following points. 1, 2. The x is 1, the y is 2. 1 and then 2, that would be right here. So it's positive 1, so right 1, positive 2, up 2. Next one, 4, negative 2. This is my x, so right 4, down 2. Right 1, 2, 3, 4, down 2. Next one, 0, negative 3. So this means I start at the origin, but I don't go left or right. I just stay right there and then go down 3. 1, 2, 3. There's that point. Next one, negative 1, 3. I go back 1 and then positive 3, so that's up 3. 1, 2, 3. Okay, so this says left 1, up 3. Next one, negative 2, negative 1. That means left 1, down 1. Sorry, left 2, down 1. There we go. 2, 0. That means I go right 2, but then I don't go up or down. I just go right 2 and stay there. 3, negative 3. I go right 3, and then I go down 3. 1, 2, 3. That's this point right here. 2.51. That's mean. So I go right 2.5, 1, 2.5. So I'm in between these two lattice points here. And then positive 1. So that's actually going to be right in the middle here. So I've gone over 2.5 and then up 1. So not everything has to cross at one of these crossing points. We call these lattice points. So it's possible to graph them when they're not in a direct place. That's not a good word for it. I can't think of words right now. Anywho, all right, we're supposed to find all the ordered pairs for each point. Man, that's a lot of them. All right, so A, where's that at? Can't even see, these letters are so small. It's right here. So that would be 0, up 1, 2, 3. So that would be 0, 3. B, right here. This is left 2, and then it doesn't go up or down. So it's negative 2, 0. So that's a x-intercept right there. C, that goes right 1, 2, 3, and up 1, 2, 3, 4. So right 3, up 4. D, that goes left 1, 2, 3, and up 1. So left 3, up 1. So negative 3, 1. E, where's E at? Is this E? Yeah, I think that's E down there. So we're going to go left 1, 2, 3, 4, and down 1, 2, 3. So left 4, down 3. That would be negative 4, negative 3. F, this point, that's a y-intercept. It doesn't go left and right, so that's 0, and then it goes down 2. So that would be 0, negative 2. G, 1, 2, 3. So right 3 and down 3. So that would be right 3, and then down 3 would be negative. H, where's H? Over here. So we go right 1 and down 1, 2, 3, 4. So right 1, down 4, so negative 4. And then the last one, I think this is I over here. So that would be right 1, 2, 3, 4, and then it doesn't go up or down, so that would be 4, 0. Whew. Right ordered pairs found on the graph of this line. Okay, so here's an ordered pair right there. So that's a lattice point. So that's the point 0, 1. Where else did I got an ordered pair? Got one right here. That's the point 2, 0. Let's see where else. Ooh, I got one right here. That one is 1, 2, 3, 4, and then down 1, so 4, negative 1. Where else I got points? Oh, I got another one right here. So that's left 2, up 2. So negative 2, 2. We even have an extra one over here, which is left 1, 2, 3, 4, and up 3. So negative 4, 3 also works. So we could do that all day long. We could find points all day long because lines have an infinite number of solutions, and these are all solutions to whatever equation that is for that line. All right, that was a lot. Let's finish up our notes. This is 20 minutes long already, dang. All right, so we're going to go ahead and label or plot the points and label them. So we're going to graph or plot these points. This says right 1 up 4. So right 1 up 4, there's the first point, and I'm going to label that A. So that's what it means to label them, is just put the letter next to the point that you put down. Next one, this says left 5 up 4. So back 5 and up 1, 2, 3, 4. This would be B. Next, 1, negative 7. So right 1, down 7. There is C. Next one, D, left 5, down 2. So 1, 2, 3, 4, 5, down 2. Remember, X goes first, Y goes after it. So that would be D. E, 0, 10. That'd be up here. 0 means it doesn't go left or right, and then we go up 10. So this would be E. Next one, negative 8, 0. So that means I go left 8, and then I don't go up or down. I just stay right there. That is the point F. Next one, 9, 7. So I go right 9, and then up 7. Right 9, up 7, right here. So that is G, the point 9, 7. Negative 1, 7. I go right or left 1, and then up 7. There's the point H. All right, which point is an x-intercept? Here's my x-axis. F must be the x-intercept. Which point's a y-intercept? Okay, here's my y-axis. E's on that axis, so E must be my y-intercept. Notice on the x-axis, F, when we have an axis, an x-axis, the x is the number, and then the y is 0. However, on E, notice when it was a y-intercept, it's the x that's 0 instead. So when you have an x-intercept, the y ended up being 0. When you have a y-intercept, the x ends up being 0. You can't see all that stuff. All right, some interesting stuff now. Find the distance between A and B. This is called AB. So the distance from A to B. So here's A and B. They are horizontal from each other, so I can just count out the distance between them. So starting at B, I'm going to go 1, 2, 3, 4, 5, 6. The distance from A to B or B to A, it doesn't matter. When we do distance, there's no negative distance. So we're just going to count between them. I could have started at A or started at B. Distance on the coordinate plane, there's not going to be any negatives there. Next one, find the distance between points A and C. That's called AC. Okay, so A to C. A starts here, C's down here. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is a distance of 11 between points A and C. Distance between B and D. Let's see, where's B? Oh, here's B and D right here. So I'm going to just count down. 1, 2, 3, 4, 5, 6. That has a distance of 6 units. And finally, G and H. Here's G and H. So I'm just going to count forward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. All right, any x-intercept, that's an x-intercept, has a y-coordinate equal to 0. Any y-coordinate this was a y-coordinate, E, has an x-intercept of 0. Wow, really doing bad at showing my paper today, sorry. So the x-intercept, the y is 0. The y-intercept, the x is 0. So the opposite letter is always 0 at the intercept. That's all I got for you. That was kind of long. Hope you had fun. Bye-bye.